Let's continue in section 4.5. Let's solve the following equation. E to the x squared equals 100. Notice the variable is in the exponent. That makes it an exponential equation. In the previous examples, we took the common log of both sides and then applied a property of logs to bring the variable down out of the exponent. We're going to do something just a little bit different this time. This time we have the special base e in the exponential, and so we can use the natural log in order to cancel the base e exponential. So let's do that. Let's take the natural log of both sides. You can put parentheses around e to the x squared or not. And then on the other side you have the natural log of 100. Now you could go ahead and take the exponent x squared down in front, but that's not necessary. The natural log and the base e exponential cancel each other out, and we're just left with x squared. Maybe it's worth noting, if you would have taken the exponent down in front, you would have had x squared times the natural log of e. But what is the natural log of e? Well, that's just 1. Right? The natural log of e is asking e to what power makes e? That's e to the first. And so we would still come up with x squared even if we went the other way. Okay, so we have x squared equals natural log of 100, and now we can just take the square root of both sides, and on the left side we'll have x, and on the right side we'll have the square root of the natural log of 100, but don't forget that there's a plus or minus out in front. So there are the exact answers, 2 exact answers, and there's a decimal approximation. If we look at the calculator, I've already typed it in. The square root of the natural log of 100 is 2.146. To 3 decimal places, we'll round it off. We'll get 2.146. So plus or minus 2.146, and we're done. Okay, let's do another example. This one's going to be a little bit harder, and let me write it out first, and then I'll tell you why it's harder. The thing that's difficult about this problem is that now we have the variable in the exponent on both sides of the equation, and we have not had that before. So the initial steps are the same, taking the log and then bringing the exponent down. Those are the same, but then there's a little more algebra to finish up the problem. So let's go ahead and have a look. So again, we'll start out like we did in the previous video. In examples 1 and 2, we'll take the common log of both sides. And then that allows us to bring the exponent down in front. We're going to have parentheses around x minus 1 in order to hold it together as that factor being multiplied by the common log of 4. On the other side, you have 2x multiplied by the common log of 3. Okay. And so then we want to get an exact answer. We don't want to type log of 4 into the calculator right now, or the log of 3 into the calculator right now. We want to get an exact answer first and then type it all into the calculator at once. So what we're going to have to do is distribute the log of 4 to each term inside the parentheses. We'll have log of 4 times x, or I might just write it x times the log of 4, minus log of 4 times 1 times negative 1 is minus log 4. And then on the other side, we can put the x out in front, and we can have 2 times the log of 3. Okay, and now we have 2 terms that have x in them, and we have 1 term that does not. So we're going to group the x terms together on one side. And I guess what I'd like to do, I'd like to get the x over to the left and the constant over to the right. So, let's keep x times log 4 where it is. And then let's subtract x times 2 log 3 from both sides. Minus x times 2 log 3 from both sides. And then this log 4 is going to be added to both sides. So it'll cancel over here and it'll come up on the right side. Okay, now we have the x's together on one side. We need to factor the x out of the 2 terms. So we can factor out the x, and what are we left with? We're left with the log of 4 minus 2 times the log of 3 is equal to log of 4. And then we just want to divide both sides by the coefficient on x. And so we'll have x is equal to log of 4 divided by log 4 minus 2 log 3. And that's a good answer. I'll go ahead and put a box around it right now. I'd be happy for you to get that answer as your exact answer for this problem. However, we could also make it look a little bit nicer. And the way we could do that is we could apply some properties of logs. So look at this 2 here being multiplied by the log of 3. We can take that 2 and we can make it the exponent on 3. So maybe I'll write it out to the side here. 2 times the log of 3 is the same as the log of 3 squared, which is the same as the log of 9. So I'll write that. I'll write the log of 4 divided by log 4 minus log 9. Sometimes students want to cancel the log 4 in the numerator and denominator, and of course that's not allowed, because in the denominator that log 4 is not a factor. There is another simplification you could do. Log 4 minus log 9, remember the difference of 2 logs can be written as the log of a quotient. And so in the denominator, we could rewrite this as the log of 4/9. And that would be the best exact answer, because that would be the simplest form of the exact answer. So again, I'm happy with this first answer, but if we see the simplification there, the denominator, then let's go ahead and try to do it. Then we just need to type that into the calculator. And if we round to 3 decimal places, we should get negative 1.710. And we're done.